So far we've worked a lot with writing linear equations and graphing linear equations and using linear equations to model. But one thing we need to make sure we're comfortable with is solving linear equations, because they won't always be in nice forms like y equals mx plus b. And here we're really just focusing on having one variable x that we need to solve for. So hopefully this should all be review, but we need review every now and then, so I hope this will be helpful. So here's our first one, pretty straightforward. We need to solve for x, meaning we need to get x by itself. First step, I would add 600 to both sides. So that gives me 10x equals 400 plus 600 is 1000. Last step, I need to get rid of that 10, so I divide both sides by 10, and I get x equals 100. The key when you're doing this is kind of to work from the outside in. What's farthest away from x and then what's closest to x. The 10 is obviously much closer to x since it's being multiplied by it than that negative 600 is. So I had to take care of the negative 600 first and move it before I could take care of the 10. Okay, next step. If you have parentheses like this, you need to take care of them first. So we need to distribute as our first step. So I do 2 times x and 2 times negative 3. That gives me 2x minus 6 minus 17 equals 13. And then I have negative 3 times x and negative 3 times 2. So first, I'm going to simplify the things I can on each side. In other words, on the left side I have 2x minus 6 minus 17. So I can combine the like terms. Negative 6 minus 17 gives me negative 23. Over on this side I can do 13 minus 6, which is 7, minus 3x. Now I want to combine like terms on each side. So I'm going to add 3x to this side, or to both sides, excuse me. So to get rid of it there, and give me 5x here. Then I'm going to add 23 to both sides, and I get 5x equals 30. And then I divide both sides by 5, and I get x equals 6. So distribute first. Go ahead and simplify each side as much as you can, and then start moving all the x's to one side and move all the numbers to another. So if you have x's on both sides of the equation, get all the x's together on one side and everything that doesn't have x on the other side. Okay, now, if we have something like this with a fraction, the easiest thing to do is to get rid of the fraction first, or the fractions, I should say. And the way we do that is by multiplying by the common denominator. So we look here and we have a 2 and a 5. So we need a number that will cancel out both 2 and 5. So you have to think of the smallest number that's divisible by both 2 and 5. And that number would be 10. So I'm going to multiply every single piece here by 10. So I can reduce these, because 10 into 2 is 5, 10 into 5 is 2, and 10 into 5 is 2. So that gives me 5 times 3x, which is 15x, 2 times x, which is 2x, and 2 times negative 39, which would be negative 78. And then we subtract 2x from both sides. We get 13x equals negative 78. Divide both sides by 13. You get x equals negative 6. So when there are fractions, you need to get rid of them by first multiplying everything by a least common multiple, or the common denominator, or something that will cancel all those denominators out is really what you want. Okay, so on this one, okay, we have an x, we have a 5, and we have a 2x. Okay, so we need something that can cancel all three of those things out. So it's going to have an x, and it's going to have to be divisible by 2 and 5. So this time we'll actually multiply by 10x. Because you're looking for the smallest thing that all the denominators can go into. So here the x's cancel, leaving me with just 10. 10 times 1. Here a 5 cancels out with a 10 to make it a 2, so I get 2x times 1. Here the x's cancel, and the 10 divided by 2 gives you 5, so that becomes 15. Okay, then I can subtract 15 from both sides and divide both sides by 2. So I get x equals negative 5 halves, or negative 2.5 would also be acceptable. Okay, last example. Notice not all three have a denominator here, so you can just kind of understand that there's an understood 1 at the bottom. This time, the thing we need to multiply by is a binomial. It's got two things, so it's x minus 3. Because I want to get rid of that x minus 3. The whole goal is to get rid of the denominators. Fractions just make it more complicated, and we don't want that. So multiply every single piece by x minus 3. So that cancels out here and leaves you x. That cancels out here, leaves you 3. But it does not cancel out on the 9, so we have to do 9 times x minus 3. So now this looks kind of like our second example, where we need to begin, or next we need to distribute. So 9 times x and 9 times negative 3. Okay, I can go ahead and say 3 minus 27, and that will give me negative 24. Then I can subtract 9x from both sides, get negative 8x equals negative 24, and then divide both sides by negative 8. And you get x equals 3. So hopefully this is helpful to kind of give you a review of some things you've seen in the past classes. The key is just solving for x and doing things in the correct order, just as you saw here. Some good pages for practice in our books is on page 92.